Welcome to the Code with Reza channel. My name is Reza and I'm here to teach you Python. Today I want to talk about exceptions. Let's start with dividing 1 by 0 and run this. It throws the 0 division error and the message is division by 0. So we receive an exception. Now let's look at another way that we can get an exception. For example, let's get an input, integer input from user and test it to see if it is integer or not. So I will say while true, x equals input, please enter a number. This function input gets something in character from the user, but it always returns a string. So we need an integer. So we cast it to integer. We pass it to integer function to get an integer. Now let's run it. Here, please enter a number. I can say 1, 2, 3 in a loop. It always asks for number. What if I enter something which is not a number? For example, R. Another exception. It says value error. This is the exception now. Invalid literal for int with base 10 and what we entered is R. So whenever we do something which is wrong, the code throws an exception. If we enter a non-integer character here, it will throw a value error exception. Now let's put this code in a try block and catch the exception. If we don't catch the exception like here, it breaks the code and exits the application. It exits the program. The program will crash. But we can accept it and handle it. So let's say I can introduce a try block, which you can find in almost all other languages too. So I would say try, except. This is for catching the exception. The name of the exception that we are interested in, and in here we handle it. So we will say print, oops, that was not a valid number. So let's run it. Okay, it says integer number. I can say 1, 2, 3. How about R? Look, it doesn't crash. It doesn't come out of the application. We handled it. It shows us a message. Oops, that was not a valid number. And then it goes back to the beginning of the loop and says, please enter a number. So we can add number and continue. As we can see, it doesn't terminate the program and tries to get a number again. A try statement may have more than one except clause. For example, we want to handle different exceptions, not only one exception. We want to handle value error, runtime error, and name error. How do we do that? We easily put the parentheses here and we say, for example, this one, runtime error, name error. So anything that happens which is of this type or this type or this type, we can catch it in here and process it. Now let's create and raise an exception ourselves. For this, let me remove this code and would say try. We raise an exception using the raise keyword, like throw in other languages. We throw an exception in some other languages. Here we raise an exception. We want to make the exception as type of exception and we enter, for example, Reza and the second parameter Ahmadi. Now let's catch this using the except keyword. We want to catch the exception. Okay. We want to access the instance that is created because when we say raise exception with this parameter, it creates an instance of this class, of this exception class. So what we are interested here is to access to that instance. So we'll say accept this exception as something, anything. For example, instance. Inst for instance. So by inst now we have access to that instance which is being created for us. So first let's check the type. With type we can check the type of that instance. So for here, we need to print it so that we can see it. Type of the instance. We can also, well, let's run it. The type of the instance is class exception. This is the type, which is true because we created an instance of the exception class. Another thing that we can check is the arguments that we pass to the exception. How can we access the arguments? It's very easy. Let's print it. The way that we access is the instance object dot args. This args returns this args. So let's run it and have a look. Look at here, Reza Ahmadi. These are the arguments of that instance. Now look at the interesting thing. X and Y equals int dot args. We are, if you can remember, we have talked about it. We are unpacking the arguments here. So we put the first thing into X and the second one into Y. So easily we can now print X equals, and we can say print Y equals. Let's run it. Look, X is Reza, Y is Ahmadi. So basically args has these two values. We unpack it. We assign the first one to X and the second one to Y, and then we print it. Try except statement has an optional else clause. It is useful for code that must be executed if the try clause doesn't raise an exception. So let's look at this. I will say try x equals 1 divided by 2, which is totally fine. Then I will say and accept zero division error. So what happens if zero division error happens? Then we will print oops. What if exception doesn't happen? What if everything goes very well without any problem? We can say else if everything is fine, then print looks good. So in here, the execution first comes here, this here. If this is fine and there is no error, it comes here. But if it's here and any error happens, this then comes here. So one of these two will be executed, either the accept or the else, not both of them. If we want to show something which always, regardless of the error, always is shown, we should come here and say, for example, printer always executed. Okay, so let's trace this code and run it and see what's happening. 1 divided by 2, there's no problem with that. So it comes and jumps to the else, it prints looks good, and then comes out of the try block. This is the try block, and then it reaches print always executed and prints this one. So let's run it. You get here, looks good, which is in the else, and then always executed, which is in here. Now, what if I say 1 divided by 0? This causes an exception. So we jump into the except, oops, we ignore the else, but it is always executed because it's outside the try. So let's run it. Oops, which is here, ignores this one, and then runs this one. It always gets executed because it is outside the try. So this is the else. In other languages, how we handle it, because there are a lot of languages that they don't have else, the concept of else. So if we run something and we want to continue the execution, if everything is fine, we can put this one under this. We don't need else anymore. So if this is executed very well and fine, then we come here. But in Python, there is a specific block for that, which means is everything is good, then come here and run this. If you need to determine whether an exception was raised but don't intend to handle it, a simpler form of the raise statement allows you to re-raise the exception. What I'm trying to say is an exception happens, you want to catch the exception, you want to, for example, log the error, but you don't want to handle it, you want to let it go. So what we do in this case is this. We say try raise, for example, name error, Reza, except name error. We just want to log it here. Just want to log here. So we say print logging the error. And that's all. We want to let the exception to continue its way through other parts of the system. We don't want to handle it either here. We don't want to stop it here. So we just say raise. By doing the raise, we are rethrowing that exception. So we are here saying just do something with it, but let it go. Just raise it. Let other people, other parts of the code handle it. This is for this one. And let's move on. The try statement has another optional clause which is intended to define cleanup actions that must be executed under all circumstances. And that is finally. So here we can say try, we raise an exception, and we say finally print by world. So it doesn't matter what happens here. If there is an exception, if there is not an exception, whatever happens here, this finally has to be executed before it finishes. So let's run it and see what happens. Look at here, raise exception, exception. So we have really raised the exception here. But at the end, before we finish the code, they finally will be executed again. So look at here, goodbye world. So this is for the operations that has to be done before you finish your program. For example, you have opened a file, you want to close the file. Either everything is successful or there is an error, you want to close the file. Or for example, you have a connection to the database. It doesn't matter if you have an exception or not. If anything goes wrong, you still want to close that connection to the database. So you put all those things that has to happen or have to happen in this block. Now let's look at an interesting example. Guess what is going to happen in the below code, in the code that I'm going to write for you. It's a function, bool return, it returns a boolean. In the try, we return true. And then finally, before we finish this method, we return false. What do you think happens here? If I say print and call the bool return, what do you think we'll see? In try, we are returning true. So normally we should get true. But the finally changes everything. Finally says before anything, the last thing that happens in here is this one. So the last thing that happens is return false. So we see the false. Let's run it. Look at here. It's false. Now let's look at a little bit more complicated one. So we define a function divide x and y. We have a try here. Result equals x divided by y. You want to catch the exception zero division error. If the zero division error happens, we want to print division by zero. If nothing happened, if everything is successful, we want to say print result is the result. And finally, it doesn't matter if it goes to accept or goes to else. Whatever happens, finally, this should happen. Print executing finally clause. We divide. If everything goes well, we come here and say this is the result and we print this. If anything goes wrong, we show division by zero and then again this finally. Finally is always shown. So let's run it. Divide, for example, 1 and 2. Get here, the result is 0.5 because we don't have any problem, so we come to else, and then finally is executed. But if I say 0, division by 0, the except block gets called, and again the final is happening at the end. Now let's talk about another topic, which is exception groups. In so many other languages that I know, we can only raise or throw one exception at a time. You cannot raise more than one exception or a group of exceptions. But in Python, you can do that. We can raise more than one exception if you want. We just need to add all the exceptions that we want into a group and then raise that group, which is interesting. Let me show you. Let's define a function f and exceptions. For example, this is for exceptions. It's a list. I want to say OS error, which is error 1 as a message, and system error, and as a message, error 2. This is a list of exceptions, and I can raise exception group and pass a message. For example, there were problems and pass this list of errors here and close the parentheses. So in here we can group these two exceptions together. We create an exception group based on these two, and then we raise the whole thing. So we raise two exceptions at the same time. Let's call the function and see how it works. Look at how the exception is printed. It says exception group. This is the message, and it shows the error one and error exception one and exception two here in this nicely formatted text. We can also do one final thing with the exception, and is adding notes to the exceptions. So let me show you by a sample. I can say try. I want to raise an exception. For example, type error. I want to say as a message bad type. I want to catch it, so I will say except type error, and I want to instance exactly the instance of the error which is thrown. I will say as E. I don't want to handle it. I don't want to log it. I don't want to do anything. I just want to add a note here. For example, I want to say E dot add note. I would say, for example, add some information. That's all. And then I would say raise. I rethrow it again. Pass it to the rest of the application. So let's run it. Look at here. There is a type error, which is the message is bad type. And we are not handling it. We are throwing it so we can see the exception on the screen. And here we just added a note, add some information, and the note is here. So for example, you have different parts of the system are calling each other, and an exception suddenly is raised. So different parts get the exception, they don't want to handle it, they just add some information to that and then rethrow it, re-raise it. So at the end, when the main caller gets the exception, it has a lot of information into exception. That's all about exceptions in Python. This was the part 7 of this tutorial, and I hope you enjoyed it. These videos are designed to be short and quick but complete. So please don't forget to watch this video a couple of times if you need it. I will upload the next part in the next couple of days. Please subscribe if you don't want to miss it. Thank you for watching, and see you later.